For the problem shown here, we are given the acceleration as being a function of v, 2 times the square root of v. And we're given some initial conditions that says at the time t equals 0, the initial position is 0, and the particle happens to be moving at a velocity of 4 meters per second. And we're asked to find the time at which the velocity will equal 20 meters per second. So the two quantities we have in this expression are a and v, and we know that we can relate those as being a equals the time rate of change of the velocity. And then we can rearrange this expression such that we have dt will equal dv over a, and in this case, we require that a be a function of the velocity. So we can then substitute in our expression, so dt will equal 1 over 2 times the square root of v times dv, and it's sometimes more convenient to write the square root in terms of an exponent, so we could write this as 1 over 2 times v to the minus 1/2 dv. And now what we can do is we can apply the limits of integration that are being told to us. So over here on the left-hand side, on dt, we're told that we are at time t equals 0, and we don't know what time we're going to be integrating up to exactly at this point. And on the right-hand side, we are going to be integrating from the initial velocity, which is at 4 meters per second, up to some final velocity, which we're going to be given as 20 meters per second, but I just want to leave it as a function. And we will then add in 1/2 v to the negative 1/2 dv. All right, so this is the expression that defines our motion right now. All right, so what we're going to do is integrate both sides of this equation. So on the left-hand side, we simply end up with t, and on the right-hand side, well, the 1/2 is a constant, and then we are v, and then it's minus 1/2 plus 1 divided by minus 1/2 plus 1. That's just writing out the integration explicitly, and the limits of integration are from v final, or from 4 meters per second up to v final. So we can go ahead and substitute our information in here, or we can actually simplify it one more step before we do that. So simplifying one more step, we will end up with 1/2. Well, this is going to be v, so minus 1/2 plus 1/2 is just 1/2. And over here, minus 1/2 plus 1 again is just 1/2. So these two are going to cancel, and we're left with, let me just write the limits of integration one more time, and then we're simply left with the square root of v from v final at 4 meters per second. So our final expression is that the time will be equal to the square root of v final minus the square root of 4, and finally t equals the square root of v final minus 2. Now we're substituting the value for v final, which was given to us, so the time that we're looking for will be t equal to the square root of 20 minus 2. Of course, we could simplify that to being 2 times the square root of 5 minus 2, and numerically this works out, solving for 3 significant figures, to 2.47 seconds. All right, so that's the first answer that we're working under. Now, the next thing we're asked is to find the displacement of the particle at t equals 2 seconds. So just write it here, find displacement at t equals 2 seconds. So what we need to do is rearrange this equation up here such that we have the velocity as a function of time. So this isn't too difficult. That will give us this, if we just look at it, we have the square root of v, I'll just leave it as v now, it doesn't have to be v final, equals t plus 2, and if I square both sides, we have v equals t plus 2 squared, or to work out the square, it would be t squared plus 2t plus 4. All right, so now we're looking for displacement as a function of time, and in this case, we are looking for a relationship between v, t, and s, and we know that v is defined as the time rate of change of the position. So what we want to do is figure out the position, so we'll rearrange this to give me ds is dv dt, or v dt. So we'll integrate both sides, so from ds, we are going from 0 to this value that we're looking for, and this will be equal to t squared plus 2t plus 4, and the limits of integration here are from 0 to 2. So quickly integrating this, the left-hand side is, so integrating this, the left-hand side, let me change the color of the pen just so it's clear, we have s will equal 1/3 t cubed plus 1/2 2t squared plus 4t, and the limits of integration are between 2 and 0. So that gives us s equals 1/3, 2 cubed, plus the 1/2 and 2 cancel, so this is just 2 squared, plus 4 times 2. And this gives me 8/3 plus 4, so that would be 12/3, plus 8, so 24/3. And that gives me 36 plus 8 is 44, so 44/3, which in decimal form works out to being 14.7 meters. And that's our final answer. S equals 14.7 meters at t equals 2 seconds.